Welcome, dear students. In this video, let us continue with the remaining chapter of trigonometry. So subject geometry, standard 10th, chapter 6th, topic trigonometry, module 5. Let us see the objectives of this video. We are going to revise about the application of trigonometry. In the application of trigonometry, we are going to revise the basic concepts. First is line of vision. Second is angle of elevation. Third, angle of depression. Using these terms, we are going to solve examples from the textbook. Let us recall the formulas that we have seen in our last videos. So we had seen the trigonometric ratios. First is cot theta is equal to adjacent side upon opposite side. Cosec theta is equal to hypotenuse upon opposite side. Sec theta is equal to hypotenuse upon adjacent side. Next we had seen about the relation between trigonometric ratios. So first is cosec theta into sin theta is equal to 1. Sec theta into cos theta is equal to 1. Cot theta into tan theta is equal to 1. Also we had seen the formula of cot theta, that is cos theta upon sin theta. Next we did trigonometric identities or the trigonometric equations. So the three trigonometric equations which we have seen are sin square theta plus cos square theta is equal to 1. 1 plus cot square theta is equal to cosec square theta. 1 plus tan square theta is equal to sec square theta. Now let us see the concept of application of trigonometry. We have already seen some based on the application of trigonometry, and also we have seen certain concepts based on application of trigonometry. Let us revise these concepts over here as well. Let us learn some concepts before studying application of trigonometry. We have already seen these concepts in previous videos. Now let us revise it once more. So suppose there is a person who is looking at the building. If there is an object situated at point B, then from the observer, that is from the point A, there is a straight line that forms. That line is called as line of vision. So line of vision is basically the line which forms between the observer and the object. So if the observer is standing at location A, looking at an object at B, then line AB is called as line of vision. Now here in this picture, you can see that there is a person standing in front of a building. Wherever the object might be on the top of the building or at some floor or below, wherever the object might be, still when a person he looks at that object, but the one line that forms from the eye of the observer, the line that goes straight, is nothing but horizontal line of vision, or also called as horizontal line. Now suppose the person is standing on the ground and he is looking at an object which is on the top of the building. So first of all, this will be the horizontal line. The line that goes straight is a horizontal line. Now when he is looking at an object situated upwards, so between the object and the observer or the person, the line that forms is line of vision. So between line of vision and horizontal line, there forms an angle over here. So this angle is nothing but angle of elevation. So angle of elevation is formed when we see above the horizontal line. So the definition of angle of elevation is if the observer at A observes the point B which is at a level higher than A and AM is a horizontal line, then angle BAM is called as angle of elevation. Now suppose here the person is standing on the top of the building and he is looking at an object situated down or on the ground. So first of all, this is horizontal line. The line that goes straight is a horizontal line. But when he is looking down at an object, the line that forms between the object and the person or the observer is called as line of vision. So between the horizontal line and line of vision, there forms an angle. That angle is called as angle of depression. So basically angle of depression is formed when the person is looking below the horizontal line. The definition of angle of depression is if the observer at A observes the point C which is at a level lower than A and AM is horizontal line, then angle MAC is called as angle of depression. So now we had seen or we have revised the concepts on application of trigonometry. Now let us move forward to the problems based on the application of trigonometry. Some problems we have already seen in our previous videos. Now the remaining sums we will do here. Now let us see the second question of solve example. The question is, from the top of the building, an observer is looking at a scooter parked at some distance away. Make an angle of depression of 30 degrees. If the height of the building is 40 meters, find how far the scooter is from the building. And in the bracket, they have given us the value of root 3, that is 1.73. So as you can see in this picture that there is a building, and on that building there is a person, he is standing, and at some distance from the building there is a scooter. So the person is observing the scooter which is parked at some distance. When he is observing, it means he is observing downwards, which means he is making an angle of depression. So he is making an angle of depression of 30 degrees. So, and also they have given us the height of the building, that is 40 meters. So we need to find the distance of the scooter from the building. Now let us formulate this question in the form of diagram. So AB is the building. A scooter is at C. So here the scooter is at C, which is x meters away from the building. A is the position of the observer. Now let us join point A and C. AM is nothing but horizontal line. AC is nothing but line of vision. And angle which is formed between horizontal line and line of vision is called as angle of depression. So measure angle MAC is nothing but angle of depression, which is 30 degrees. Now as you can see in this diagram, angle MAC and angle ACB are both alternate angles. So if measure angle MAC is 30 degrees, then measure angle ACB will also be 30 degrees. Now in this question you can see that height of the building is given and we need to find the distance of the scooter from the building. So if you consider angle C as theta, so height of the building is nothing but opposite side of this theta, which is AB, and we need to find the adjacent side, that is BC. So the trigonometric ratio which is related to opposite side and adjacent side is nothing but tan and cot. So here we are going to use tan theta. Now tan 30 degree or tan theta is nothing but opposite upon adjacent, which is AB upon BC. The value of tan 30 degrees we know already from the table, that is 1 upon root 3. The value of AB, that is height of the building, is nothing but 40. So let us substitute it over here. And the value of BC we have considered as x. So let us substitute this value of x also over here. So we need to find the value of x. So therefore we get x is equal to 40 into root 3. Now as you can see in the question, they have given us the value of root 3, which is 1.73. So let us substitute that value over here. So we will get x is equal to 40 into 1.73, which is equal to 69.20 meters. Therefore the value of x is nothing but 69.20 meters, and x is nothing but the distance of the scooter from the building. So therefore the scooter is 69.2 meters away from the building. Now let us see the next sum. To find the width of the river, a man observes the top of a tower on the opposite bank, making an angle of elevation of 61 degrees. When he moves 50 meters backward from the bank and observes the same top of the tower, his line of vision makes an angle of elevation of 35 degrees. Find the height of the tower and width of the river. In bracket, the values are given of tan 61 degrees, which is 1.8, and tan 35 degree, which is 0.7. So now you can see in this diagram, in this picture, that a tower is there which is situated on the bank of the river, and on the opposite side of the bank of the river there is a person who is standing and he is looking at the top of the tower. So when he is looking at the top of the tower, it means he is looking upwards. So he is making an angle of elevation of 61 degrees. Afterwards, he moves some 50 meters behind or backward from the bank, and again he observes the same top of the tower. So from there he makes a line of vision. From there his line of vision makes an angle of elevation which is 35 degrees. So we need to find the height of the tower and width of the river. So let us see. Now suppose segment AB shows the tower on the opposite side. So let us give the name of this tower as segment AB. Now A is the top of the tower and segment BC shows the width of the river. So suppose BC is nothing but width of the river. Now let H be the height of the tower. So let us consider the height of this tower as H, and X be the width of the river, which means segment BC is equal to X. So from the bank of the river, the person observes the top of the tower. So he is making a line of vision, that is AC. So between the line of vision and horizontal line, he makes an angle of elevation which is 61 degrees. After that, he moves some 50 meters backward from the bank of the river. So suppose he moves at a point D, and then again he observes the top of the tower, making an angle of elevation of 35 degrees. So now let us consider tan 61 degrees as H upon X. Okay, let us consider the triangle ABC. Now in this triangle ABC, we have the value of theta, that is 61 degrees. So here again we have relation of opposite and adjacent. So we are going to use tan theta here again. So tan 61 degrees is H upon X. Now the value of tan 61 is already given in the question, that is 1.8, which is equal to H upon X. So therefore H is equal to 1.8 into X. Now multiplying by 10 on both the sides of this equation, we will get 10H is equal to 18X. Let us consider this as equation 1. Now let us consider the big triangle here, that is a right angle triangle A, B and D. As the tower is perpendicular to the ground, so therefore AB is perpendicular to BC. So therefore in triangle ABD, angle ABD is 90 degree. So in this triangle, let us consider angle D, that is 35 degree. So again we have opposite upon adjacent ratio, that is tan ratio. So tan 35 is equal to opposite side is h and adjacent side is nothing but BC plus CD, which is x plus 50. So tan 35 is equal to h upon x plus 50. Now the value of tan 35 is already given in the question, that is 0.7 is equal to h upon x plus 50. Therefore h is equal to 0.7 in bracket x plus 50. Again multiplying both the sides by 10, we will get 10h is equal to 7 in bracket x plus 50. Now if you see equation 1 and 2, both are in the form of 10h. So they are left hand sides are equal. So we can say that their right hand sides are equal as well. So we get 18x is equal to 7 in bracket x plus 50. So solving this equation, we get 18x is equal to 7x plus 350. Therefore 18x minus 7x is 11x, which is equal to 350. Therefore x is equal to 350 upon 11, which is equal to 31.82. Now x is nothing but BC. So we can say, now let us substitute the value of x is equal to 31.82 in equation 1. So we have 10h is equal to 18 into x. So which is equal to h is equal to 1.8 into x, which is equal to 1.8 into 31.82, which is equal to 57.28 meters. H is nothing but height of the tower and x is nothing but width of the river. So we get both the values, width of the river as 31.82 meters and h, that is height of the tower, as 57.28 meters. Now let us see the next question, fourth one. Roshni saw an eagle on the top of the tree at an angle of elevation of 61 degrees. While she was standing at the door of her house, she went on the terrace of the house so that she could see it clearly. The terrace was at the height of 4 meters. While observing the eagle from there, the angle of elevation was 52 degrees. At what height from the ground was the eagle? In the bracket they have given, find the answer and correct up to nearest integer. Also they have given values of some trigonometric angles. So tan 61 degree is equal to 1.80, tan 52 degrees is equal to 1.28, tan 29 degrees is equal to 0.55, tan 38 degrees is equal to 0.78. Also they have given the diagram. Now in the diagram you can see that PQ is the house. Suppose PQ represents the house and SR represent the tree. So now eagle is at point R. Now let us draw segment QT perpendicular to RS. So segment QT is perpendicular to segment RS. Quadrilateral TSPQ is a rectangle. So there forms a quadrilateral which is TSPQ, which is a rectangle. Now the terrace was at a height of 4 meters. So PQ is equal to 4 meters. So therefore TS will also be equal to 4 meters because they are opposite sides of rectangle. Now let us suppose SP as X and TR as Y. Now we need to find the height of the ground to the eagle, that is at what height from the ground was the eagle, which means we need to find the distance of SR or the segment SR. So now let us consider triangle RSP. So in triangle RSP, angle PRS is equal to 90 degrees minus 61 degrees, which is equal to 29 degrees. Where did it came from? It came from the formula sum of all the angles of triangle as 180 degrees. Angle SP already know, that is 90 degree. Angle RPS also we know, which is 61 degrees. So we can easily find out the remaining angle, that is angle SRP. Similarly, we can also find out in triangle RTQ, angle QRT is equal to 90 minus 52, which is equal to 38 degrees. So we got two angles. Now let us proceed further. So first of all, we are going to find out the segment. In this segment RS, there are two segments which we are going to find out. That is, we are going to find out the value of RT. We already know ST. So when we add RT plus ST, we will get the entire value, that is RS. So now let us consider triangle RSP. So in triangle RSP, tan of angle PRS is equal to opposite upon adjacent. So opposite side of this angle is SP and adjacent side is RS. So tan of 29 degrees is equal to SP upon RS. Now let us substitute the value of 29 degrees, tan 29 degree, which is equal to 0.55, which is equal to SP we have considered as X and RS we have considered as Y plus 4. Now by rearranging the terms, we will get the value of X as 0.55 into Y plus 4. Let us consider it as equation 1. Similarly, tan of angle QRT. Now, next triangle when we consider, that is angle RTQ. In triangle RTQ, let us find out the value of RT. So, tan of angle QRT is equal to opposite side of angle QRT upon adjacent side of angle QRT, which is equal to SP upon RT. So tan of 38 degrees is equal to X upon Y, where SP is equal to TQ is equal to X. Because they are opposite sides of rectangle. So tan of 38 degrees is 0.78, which is equal to X upon Y. So therefore, the value of X is equal to 0.78 into Y. Name it as equation number 2. Now when you see at equation 1 and equation 2, you can see that both the values are equal. So therefore 0.78 into Y is equal to 0.55 into Y plus 4 from equation 1 and 2. Therefore multiplying both the sides by 10, we get 78Y is equal to 55 into Y plus 4. So therefore 78Y is equal to 55Y plus 220. Therefore 78Y minus 55Y is equal to 23Y, which is equal to 220. Therefore Y is equal to 9.565. Now we have to correct this number to nearest integer. So when you correct it to the nearest integer, we get the value as 10. So therefore Y is equal to 10. Y means RT. So we got the value of RT as 10. We have the value of ST as 4. So we can find out the value of RS. RS is equal to Y plus 4, which is equal to 10 plus 4, which is equal to 14. So therefore the eagle was at a height of 14 meters from the ground. Now let us see the fifth question. A tree was broken due to storm. Its broken upper part was so inclined that its top touched the ground, making an angle of 30 degrees with the ground. The distance from the foot of the tree and the point where the top touched the ground was 10 meters. So what was the height of the tree? So here we need to find out the height of the tree. So let us consider the height of the tree as AB. Let us consider the tree was broken at point C and its top touched the ground at point D. So let us join BD. As we know, the tree was perpendicular to the ground. So the broken part made an angle of 30 degrees with the ground. We also have the distance of the tree from the foot of the tree till the top where it touched the ground as 10 meters. So we need to find the height of the tree. Suppose AB is the tree, it was broken at C and its top touched at D. Angle CDB is equal to 30 degrees, BD is equal to 10 meters. Also we can see that CA is nothing but CD. So we can say that CA is equal to CD. So now here you can see some triangle, so which is a right angle triangle CDB, where angle CDB is 30 degrees. So we can use some trigonometric ratio over here. So we have adjacent side and we need to find out BC, which is opposite side. So we are going to use tan ratio. So tan 30 degree is equal to opposite upon adjacent, which is equal to BC upon BD. Tan 30 degree we already know from the table, that is 1 upon root 3, which is equal to BC upon BD is also given, that is 10. So let us substitute all those values over here. So therefore we get the value of BC is equal to 10 upon root 3. Now we have the value of BC, but we need to find out the height of the tree, that is the entire value AB. So therefore we need to find out first the value of AC, because we have the value of BC. So if we find out the value of AC, then we can add AC plus BC is equal to AB. So before finding the value of AB, we can also find the value of CD. If we find out the value of CD, then we can get the value of AC, because AC is equal to CD. So now, in order to find the value of CD, we can use the formula or the trigonometric ratio of sine. So sine 30 degrees is equal to BC upon DC, which is equal to sine 30 degree we already know, that is 1 upon 2, which is equal to BC we already found out, that is 10 upon root 3, the whole upon DC. So therefore DC is equal to 10 into 2 upon root 3. Therefore DC is equal to 20 upon root 3. Now we got the value of DC, so we can find out the value of AB. So AB is equal to AC plus BC. So therefore AB is equal to 20 upon root 3 plus 10 upon root 3, where AC is equal to DC. So 20 plus 10 upon root 3 is nothing but 30 upon root 3. So that therefore AB is equal to 30 upon root 3. Now we have to remove root 3 from the denominator. So therefore we are going to multiply root 3 in the numerator and denominator as well. So therefore we get AB is equal to 30 into root 3 upon root 3 into root 3. Therefore AB is equal to 30 into root 3 upon 3. Therefore AB is equal to 10 root 3. So we get the value of the height of the tree as 10 root 3. So I hope you all have understood today's video. The next sums we will be solving in our next lecture. Thank you.